Hi, everyone. Thanks for making the time today. My name is Jesse Lovelace. I am a software developer turned solutions engineer specializing in DevOps. Today, we're going to be talking about leveraging CircleCI for DigitalOcean Kubernetes deployment. We are recording this webinar, and the recording will be sent to the participants after, and we'll have a Q&A at the end as well. So if you type your questions into the questions section of the GoToWebinar interface, we'll go through those at the end of the presentation. I'll be able to take questions about CircleCI, about DevOps in general, general Kubernetes, but for very specific questions about the DigitalOcean Managed Kubernetes service, we'll have to follow up with those via email. So let's get started. So CircleCI's mission is to make it as easy as possible to go from idea to delivery. So what we mean here is taking your code from wherever it lives in the VCS somewhere to getting it where it needs to go. And along the way, building, testing, scanning for security issues, all those kinds of things, and then delivering it to its final endpoint. So where does CircleCI sit in the tool chain? So CircleCI sits in this middle tier that we like to call the orchestration tier. On the left, we have your creation, where you're going to be collaborating. You're going to use resource control, whether that's GitHub, Bitbucket, and in the future, Visual Studio. Once you commit your code, it's going to be picked up by CircleCI automatically. We're going to build it, we're going to test it, and then we're going to deliver it to whatever your endpoint might be. So in this case, we're actually focusing on DigitalOcean and their managed Kubernetes service. So some of the features of CircleCI are its ability to optimize your builds. What we mean by this is that CircleCI can take your code and it can split it into parallel jobs so that it runs very quickly. We have the ability to actually even split your unit tests across multiple containers so that they can run much more efficiently and in much less time. We have the ability for you to configure your resources that your jobs run on. So that means increase the CPU power by adding cores, increase RAM. We can do that on a per job basis and even at the branch level. Additionally, CircleCI has custom caching to speed up your builds. So this means not just artifact caching, but also the ability to utilize Docker layer caching. So another feature of CircleCI is its package management system. That's called orbs. And orbs is basically a reusable, shareable package of CircleCI configuration. We'll actually be utilizing quite a few orbs today as we configure jobs to build, be pushed out to container registries, and then be deployed to a Kubernetes cluster. So there's a ton of orbs already out there pre-built for all kinds of different integrations that you want to use, whether those are security scanning, metrics and log aggregation. We have orbs for all different kinds of cloud providers, including DigitalOcean, and much, much more. So what's DigitalOcean Kubernetes? DigitalOcean Kubernetes is a managed Kubernetes service designed for simple and cost-effective container orchestration. Now, as you'll see in a second, the DigitalOcean Kubernetes service is really, really easy to use. And it's very easy to set up and get running and start testing your applications against. So before we dive into the actual nuts and bolts of the demo, let me talk a little bit about how we write jobs in CircleCI. So the CircleCI job configuration file is just a single file that lives within your code repository. And in that file, that YAML file, we actually write out our job definitions. Right here, I've got a very, very simple job that is a build job. I label it whatever I want to call my job, but in this case, I'm calling it build. And each job has a location that it runs on. So in this case, it's going to be a Docker image, specifically a Golang Docker image. This could also be a virtual machine, and we have other kinds of machines that it can run on, such as Mac executors and such. After that, we have the steps. So in this case, this is the simplest job that you could think of. It's basically just checking out your code from your version control system, and then it's building your code. Next concept I want to talk about is workflows. So workflows basically orchestrate jobs. So if you've got a couple different jobs defined and you want to put them into a workflow, which is an order of your jobs to execute in, then you define a workflow. In this case, I've called this workflow production flow, and I've got a couple of jobs that I'm adding to it. So those jobs would be a job I've written for a security scan, a job I've written to build my code, a job I've written to test my code, and a job I've written to deploy my code. So we have the ability on a per job basis to set your resource class. So these mean you can add more RAM, more CPUs. If you've got super data intensive jobs, maybe you're doing some big Java compiles, or you've got a machine learning job or something like that, you might want to ask for a large or an extra large instance in order to get more cores in order to run your job more efficiently. Now, we talked a little bit about orbs earlier. Orbs basically allow you to import a pre-written set of configuration that you can use in your job definitions. So in this case on the right, I've imported a ton of different orbs: Kubernetes, GCP, AWS, DigitalOcean, Docker, Windows orbs. All of these are documented, and we have a marketplace where you can go and use all these orbs for free, look at the different orbs, see how they're written, see what kind of configuration options they take. But it really helps you get going very quickly. So one other topic I want to talk about, which I'm going to be showing in my demo, is something called matrix jobs. Matrix jobs allow you to take a job that would normally just be run as a single job and then start running it with multiple different permutations. In this particular case, I'm creating a matrix with a set of parameters, one being a version of Golang that I want to build my application against, and the other being a Chrome version that I want to test my app against. And what the matrix jobs will do is it'll calculate the Cartesian product of all those different variables and automatically create all of the jobs needed to test all those various different permutations. And then also we have this concept for certain jobs where jobs might need approval before they run. So, in certain cases, your jobs, you might want them to run automatically. Let's say that you have your software that's building, it's testing, it's being deployed out to maybe a test environment or a dev environment. But for certain workflows, you actually want to hold those because they might be going to production, and approval jobs allow you to do that. Okay, now we've talked a lot about kind of the specifics of how all these things are put together. Let's get into some practical. So here I've got my DigitalOcean Kubernetes dashboard. I want to show you really quickly how easy it is to create a new Kubernetes cluster. You simply go to the Kubernetes section under Manage, go to Create, we go down to Clusters. Here I can pick which data center that I want to create my cluster in. Let's create it in New York. I'm going to choose next my cluster capacity. So this basically is a number of nodes that I'll be able to schedule containers out onto. I can call this, my create nodes, and I can have multiple node pools if I wanted to. I could have nodes with different machine types, which would indicate that they have more CPU or RAM. And I can set the number of nodes. We're just going to keep this at 3 for now. We can add tags in order to categorize things, and then we can name our cluster, and we'll need to remember this name for usage later. So we'll call this cluster best case cluster. And I'll just hit create. All right, so that cluster is now in the process of being provisioned. Now, obviously, if we have a Kubernetes cluster, we want to be able to schedule our Docker containers onto that. So we need a place for storing our Docker containers. Now, obviously, you have lots of options here. If you already are using Docker Hub and maybe private Docker Hub registries, you can go that route. But it turns out that DigitalOcean actually has their own Docker registry. And so if you go down into Images and into Container Registry, you can actually create your own container registry within DigitalOcean, which allows things to be kind of all in one place, very easy authentication and deploying those images out to your container registry and then pulling those in from the container registry into your Kubernetes cluster. Now, one thing before you get started with your own integrations, and what I had to do to set this up is to make sure that you go and get an API key. You create a new API key here by saying generate new token. You call your API key whatever you want to do. You generate a token out. Now, when I hit this, what will happen is it will show a secret token that would be able to be used to access this account. So I'm not actually going to generate one right here. I've already generated one beforehand. All right, now that we've seen what the dashboard looks like for DigitalOcean, we can look at actually an existing Kubernetes cluster that I have set up already. And this is what the dashboard looks like for that. If I click this button right here, I can go into the Kubernetes dashboard for this particular deployment. And you can see that I have full access to kind of the normal Kubernetes dashboard to look at all the namespaces, investigate my jobs, my deployments, all those kinds of things. Now let's look at the sample application that I've written for this webinar and see if we can start doing some interesting things with that. So here I have my code editor, and I have a very simple application that I'm calling the Dice game. Dice game is a Golang application. It's about 48 lines or so of actual Go code, but basically it's just a get handler, and it shows a little bit of output. So let's go ahead and build this. I've got my Docker file here, which is going to be important for any of your applications that you want to deploy out to Kubernetes, that you've got all this set up. But I'm going to quickly just go ahead and build my application, my Docker file. Oh, let's actually build it first. Okay, built my container. Now let's run it locally so we can see what that looks like. All right, running locally, let's go to localhost 9000, and okay, so here is my application, the Dice game. And I can click this little button and it'll roll the dice for me. So I've got 2 dice and it's rolling them. All right, so that's the dice game. Now, let's say that I want to see what this dice game looks like. I've already deployed this out to my Kubernetes cluster, so let's look at that really quickly. So here is my dice game deployed out to the Kubernetes cluster. The address I've got for it is digitalocean.knobs.io. Now, what we want to do is we want to look at, okay, let's make a change to this application, a simple change, and see what that looks like running through the CI/CD system, running the tests on it, all those kinds of things, and then let's see what happens when we deploy it out to production. So first things first, let's create a new branch for me to make a change to this application. Okay, I've created a new branch. I'm going to go to my index.html file. I'm just going to take that same button that I had before and let's change it to the danger color. Okay, I'm going to commit this. All right, and then I'm going to push this up. To my GitHub. All right, now just to make sure that I've actually changed this, let's actually look what it's seeing. Let's go ahead and build it again locally and then see what it looks like. local, let's see. Okay, great. Change my color to red. So let's go to my GitHub repository where I'm managing all of my code and see what's going on. Okay, so if we look at my GitHub of this, same view of the files as you've seen before. This is probably a familiar interface to you. And you can see that I've just pushed a new branch and it's asking me to create a new pull request for it. So let's do that. All right. So creating our pull request. Now, what you'll notice right off the bat is that CircleCI has integrated with GitHub because I've authorized it to do that. And we'll go through the flow of how I've done that in just a few minutes. But what's happening is CircleCI is scheduling up some jobs to run in order to test this application for various different things. Now, the way that I've defined my jobs is in the code in this directory here called .circleci and in this config.yaml. This config.yaml uses the same syntax that I talked about earlier, where we are importing some orbs and then we're defining some jobs. All right, so what we can see is that a lot more is happening here. CircleCI has run my security test, and then it's actually starting to do a matrix build against for 4 different versions of the Golang language. So let's actually pop into the CircleCI interface to see what's going on. Now, as you can see, the first thing I need to do before I integrate CircleCI with my project or when I go to see build status is I need to authorize with my version control system. In this case, I'm going to log in with GitHub. I've got my project here. And then this is the CircleCI interface. I can go into my repository and I can see the various different pipelines that are running. Now, pipelines are just a run of a workflow. So let's go in and see what this one looks like as it's running. All right, so what you'll notice off the bat is I have this really interesting visualization of the matrix jobs that I've defined. So my security scan has passed for this particular application. I've built it now against 4 different versions of Golang. And now in this phase, I am testing it against running my tests using binaries created by those 4 different versions of Golang, but now running those also with headless browser tests against different Chrome versions as well. So I only had to write each of these jobs once though. The matrix jobs allowed these to actually fan out and be utilized in a very powerful manner, and also to run concurrently. So what you'll see is that these aren't just running one at a time. When you actually have a CircleCI performance plan, you can have multiple different jobs run in parallel. Now, so this is a feature branch, right? And so what I'm not doing here is I'm not actually going out and deploying this to an endpoint at the moment. Now, that doesn't mean that I couldn't. I could actually deploy this out to possibly a feature branch and possibly a different Kubernetes cluster or even in a different namespace. But in this case, this example, we're just running our security scans and running our tests. Now, we've seen that all of our tests are green, everything looks good. Let's actually go back to our pull request. Okay, refresh our screen. What we can see here is that all the checks have passed. So we've got 14 successful checks. They all passed. Everything looks good. Now, if you remember earlier, I showed you what our production Kubernetes deployment endpoint looked like. It's over here on this tab. And if you can see, if I refresh it, it's still got this green button here. So let's go back into our pull request and let's actually merge this to master. So looks good, confirm merge. All right, now let's go back into CircleCI and see what happened once I merged that into master. So we can see as a new workflow is now running, is triggered by the master merge. And what you'll notice is that this workflow actually has more going on. So not just does it have our normal jobs that we're doing for security scanning, for building the application, for testing the application, but it's also got these extra jobs here. This job is called do build and push. So this job is actually where we're building our Docker image within the CI/CD pipeline, and then we're pushing it out to the Docker registry. And then we've got a hold job, which will wait for us to approve, and then we'll have finally a job that deploys this out to our endpoint. Now, while this is building, let's take a look at how easy DigitalOcean makes it to interface with these Kubernetes clusters. So the application that DigitalOcean provides that really kind of takes a lot of the legwork and all the fiddling out of working with Kubernetes clusters is called the DigitalOcean Control app, and it's just doctl. So what I do to get started with doctl is just say doctl auth init. And what it's going to do is it's going to take a token that I've got and it's going to verify it and it's going to utilize it. Now, the next thing we need to do is we actually need to integrate our authorization that we're getting from DigitalOcean with our Kubernetes cluster. And the way that we do that is we use the same command, doctl Kubernetes cluster kube config save, and then we type in our cluster name, CircleCI cluster. Okay, so what this does for us is it writes our kube config so that we can use the standard kube control application that you use to talk to your various different Kubernetes clusters. So let's go ahead and talk to our Kubernetes cluster and see what we've got on it as far as pods. Okay, so we got 2 pods out that are our demo application. This is the old version because we haven't deployed the new one out. Let's see what else we've got. Okay, and then we've got a service out that's going to be a load balancer that'll load balance requests across our 2 pods that we have running. All right, so there is 2 more steps that you need to utilize in order to actually allow your Kubernetes cluster to pull images from your DigitalOcean Docker repository. Those are a simple way for the DigitalOcean control application to get the correct manifest into Kubernetes to allow the default service account to pull those images down. Those are all documented in the DigitalOcean documentation, so I won't go through those here, but you do need to do that before your Kubernetes cluster will be able to pull the images from your DigitalOcean container registry. Now, again, while the application is still building, let's go and look at what these jobs look like in a little bit more detail. All right, here's my configuration, and I've got these various different jobs defined. First job that we see here is my build job. My build job basically does a couple different things. It takes an input parameter of the Go version that I want to use. It's using a Docker image, which is actually based on that parameter that I specified in. And so this is how I'm telling it which version of Golang I want to use as my base Docker image that I'll then check out my code onto and then build my binaries with. The steps here are I'm going to check out. I'm going to use some caching to cache my Go modules that I'm using. I'm going to build my test binary. I'm going to build my application binary. I'm going to copy some templates and all of this output of these things into something called a workspace, which allows me to persist files between jobs. I'm going to make sure my cache is up to date, and that'll be the end of the build job. The next job we have is my test job. My test job takes 2 different parameters. One is the Chrome version and one is the Go version. In this particular test, I'm actually using a Headless Chrome driver that allows me to run my Golang tests in an actual browser to make sure that my little web server application is serving up the right HTML. After that, I've got a security job, which is running an open source Go security scanner and then outputting any failures in JUnit, which CircleCI can then pick up and utilize. And then finally, we'll get to the meat of it, where I'm creating my DigitalOcean deployment. So what you'll notice here is that some of the steps in my DigitalOcean deployment actually are coming straight from DigitalOcean orb that we've already got available. And this orb actually takes care of installing the DigitalOcean control application, so that a lot of that's kind of taken out of the equation. And I'm also able to pass in securely my DigitalOcean access token. Now, the question is, how exactly am I getting this in here, and how secure is it when I'm pasting it in as an environmental variable? Let's take a look at that real quick. So first, we see that the application has built. I've built a new container here. Let's look at this job and see what it looks like. I've got my Docker container that's built. I've tagged it, and then I'm pushing it up to the DigitalOcean registry so that I can utilize it in my Kubernetes deployments later on. But first, let's see exactly how we're getting that API token into my job pipeline. And to see that, we go into organizational settings here, and we're utilizing something called contexts. Contexts are basically secure vaults for your secret data that you need to store and then utilize in your CI/CD pipelines. Within a context, I can define a set of environmental variables. The values are actually stored behind the scenes in an encrypted vault, and all of them are stored encrypted both on disk and in memory. And then they're actually pulled out using a account-specific key at runtime and applied to your CI/CD jobs. So now we've talked about context and how we're getting these secret variables needed for deployment into your workflows. Let's now go ahead and approve this job so we can push out our change that we just made into production. So I click on this whole job, and what you'll see is that I have a approval dialog. Approval dialog says, hey, are you sure that you want to actually allow this workflow to keep running? I do, so I'm going to hit approve. What will happen now is that approval will trigger this final job, which is where I'm creating my DigitalOcean deployment. And we'll actually watch this one run so we can see the steps involved. Now, the thing to keep in mind is that 90% of the code needed to do all this comes straight from the orbs. I actually didn't have to write it. I just had to import the orbs and fill in a couple variables, and it was able to do most of the legwork here for me. All right, so we can see that we're creating our Kubernetes resource, and oh, looks like we're done. All right, so in just a couple minutes, we built a container, we pushed it to a registry, and it deployed it out to a Kubernetes cluster. So unless there are gremlins in the system, we refresh our production interface, we'll see, yep. So the application has been updated to the newest version. It's picked up the change of the new button color, and how we're in business. Alrighty, so with that, let's take some questions.
If you have any questions, please feel free to type them into the questions box now. Haven't seen anything come through yet, surprisingly. How do you manipulate the Headless Chrome?
So Headless Chrome, there's a package out there called Chrome, I think it's PD is the name of it. Let's see. Oh, sorry, it's Chrome DP. And basically they have a Chrome WebDriver for Golang. And so this particular image already has the Headless Chrome installed on it. So basically all I have to do is write my tests so that they utilize the Chrome DP package. And then down in my headless browser test, what happens is I start up an HTTP server at a particular port. I'm listening, I run I create the Chrome instance so that it's running, and then I tell the Chrome what to do. I say, Chrome, go to this web address, which is just the little server that I started a few lines before, and then Chrome, go click on this particular CSS selector, and then I want you to give me the HTML that is in this particular element after the click happens, and put it in a variable called output. And then basically I can go in and do a regular expression match to make sure that the HTML changed the way that I expected it to. Good question.
How did you make this on hold step?
Yeah, so that's simply part of the CircleCI configuration language. If I go down to my workflow, what you can see is I have this little job defined. Now, what makes this job special is that it has this type approval. An approval job is a special job that all it does is it pauses a workflow until someone on your team approves the workflow to start running again. In this case, it has a before requirement, so it has a position in the workflow, so we make sure that it runs after the DigitalOcean build and push. And then my deployment actually has a requirement for the approval job. So this one won't run until the approval gets approved.
We have a few questions around the learning curve of learning CI/CD and learning CircleCI. What is the learning curve like if someone is thinking about implementing their infrastructure in Kubernetes along with CircleCI?
So CircleCI's learning curve is actually pretty small. Everything's written in YAML for one, which depending on your background, you probably already have a pretty good amount of experience with. Now, for very simple use cases, you can get those up and running, having no experience with CircleCI in 30 minutes or an hour. There's a ton of great documentation on our website that shows you kind of different use cases for the programming language and the packages you might be using. The more advanced use cases, obviously you'll have to have a little bit of background in understanding, like how Kubernetes works, how you create your Kubernetes manifest, how you deploy out images to registries. So that takes a little bit of kind of background learning. But as far as the actual CI/CD YAML, it's pretty intuitive, and you can get up and running very quickly.
Awesome. Someone has a very small team here with 4 engineers, and they have quite a few different containers to be deployed. Should they do it manually or use some time to learn CI/CD?
I would say that you should always take the time to learn CI/CD, because no matter where you're starting, it's going to get more complicated. And with complication and with hiring new people and possibly people leaving, those kinds of things, you want to have all of that pipeline as code and not just as some sort of process that a particular person has to go through to deploy things. So I always recommend, no matter how small your team is, that you utilize automating your CI/CD with something like CircleCI, even if you just had one person.
What are some advantages of CircleCI over other services like CircleCI?
So CircleCI is purpose-built for running CI/CD pipelines and workflows, and it integrates with some very popular CI/CD or version control systems out there. Not only that, but having CircleCI in your infrastructure doesn't tie you to a particular development workflow. Let's say you're using Scrum or Kanban or something like that, or a particular ticketing system like Jira or GitHub issues or something like that. It also doesn't tie you to any kind of specific way of deploying applications out. You have a lot of versatility in that. So I would say some of the big advantages are, for one, we're constantly innovating in the CI/CD space, and that's our core focus. But for two, you're able to run these jobs at a very high scale. You can integrate a lot of different VCSs coming in, and also you can integrate a lot of different deployment endpoints on the way out.
Thank you, Jesse. How secure is using user key in CircleCI?
So user key, I'm assuming you mean kind of like an API key. And since we talked today about the DigitalOcean API key, I'm going to assume that's one we're talking about. So behind the scenes, our secure contexts are actually backed by a cryptographically secure vault. And so in that sense, they're incredibly safe, right? There's very little danger of those ever being compromised out of the CircleCI context and its underlying vault security system. But obviously, like there's always a way for a developer who wants to circumvent security to do so, whether that's to write a insecure bit of pipeline code that emails your API key somewhere. I don't know. I'm just kind of making up stuff, but you can't completely plan against a developer who's trying to do something wrong. But the beauty of having things in version control and using things like pull request and team collaboration, looking at pull requests, is that you can really minimize the ability for someone to get bad code into your pipelines. So I would say the mechanism for storing the secrets in CircleCI is very secure, but you always have to make sure that you're following good practices when you're writing your CI/CD jobs.
Great. Right now, we use Helm to deploy DigitalOcean Kubernetes. Is it possible to use CircleCI with Helm?
Yeah, so we have a Helm orb. It's fully featured. It's very, very common. It's probably more common use case to use Helm than to just kind of use the manual kube control commands that I use. But in this particular example, we're trying to keep the number of different new technologies we're introducing to a smaller set. So yes, Helm is a perfectly good way of deploying it out, and we have an orb for that.
How do you use orbs?
So using orbs is super simple. So the way that you use orbs is you just import them into your configuration file using this little orb stanza. And so if you go search Google for CircleCI orbs, you'll see our whole orb registry, and you can see all the different orbs that we've got out there that do all kinds of different things, from security scanning to, like I was saying, code coverage to helping you with your deployments. And so all of those ones that you can find online on our orb registry, you can import those just by calling them at their version to pull them in here.
Is the approval step limited to the CircleCI interface, or is it possible to have a Slack integration or a different service for that?
So the approval job itself is limited to the CircleCI interface. However, you can very easily write your own job that holds a pipeline waiting for approval from a Slack integration or something like that. And we actually have a Slack integration that you can use kind of out of the box as well. So the sky's kind of the limit when you're writing these workflows. If you want to create that virtual hold, which basically is just a job that spins up and maybe it sends a text to a Slack channel or to a Slack bot saying, hey, this job's ready to go, press, somebody say yes to deploy it, or however you implement your Slack bot, then that job can just wait. And if it's a dependent step within the workflow, the rest of the workflow can't go. And so it can wait there until you get a response from somebody with your Slack integration, and it can push it forward. So no, the approval step can't be used for that. It's more specific for the interface, but you can write an approval step that does kind of anything you want.
Cool. What is the best way to deploy Kubernetes secrets as a resource in using CircleCI?
So this is somewhat of a complex question in that, Kubernetes secrets are a great kind of first step into secrets management. And what I would say is that, the best practice there is to make sure that you have those manifests where those secrets are defined and pushed in a separate project that has like limited access, and it has a very small team of your security engineers that are actually managing those secret manifests. And then they'd have their own deployment pipeline with most likely their own Kubernetes roles that allow them to write those secrets out to your Kubernetes cluster. And then obviously your actual applications, you would give them access to read those secrets in, as needed. But the better version of all of that is actually to use a real secrets vault. And you can find those online. There's various different people that write the software, but those give you a lot more control of your secrets and give you kind of auditability, and a lot more kind of fine-grained access controls.
Great. Does CircleCI integrate well with Flux CD?
That is a question I do not have the answer to off the top of my head, but we can follow up on that one.
Thanks. In general, how do you integrate pipelines into a project management process with the reviews, testing, acceptance tests, and final deploy?
So that's another tricky question, in that there's not going to be probably a cookie cutter answer. There's best practices, but each workflow is basically going to be based on your particular kind of processes and the various different gates and compliance requirements that you've got. I would say typically that using something like a Git flow in conjunction with CI/CD that has various different workflows that are triggered based on different types of feature branches. Those workflows possibly deploy out to staging areas, and then obviously you've got approvals that have to happen to bring stuff into master or into whatever your deployment branch is, and then push that out with various different gates along the way. So it's a complex question to answer in probably just a few minutes at one sitting, but I would say that there are some good best practices out there, and like what I was kind of alluding to with using things like Git flow and deployment branches and staging branches and those kinds of things. One of the things that you'll notice in my workflow down here is that the DigitalOcean deployments actually only ran when this particular branch filter matched. And so you could neck this down to be whatever you wanted: deployment, master staging, or staging just master. But the idea here is that you should be able to restrict access in your branches so that only certain people can actually merge code into these critical branches, whether you deploy from master or you deploy from another branch like a deployment branch. A combination of using filters on your various different workflow jobs allow you to make sure that only certain branches are able to even start moving a production pipeline, whereas other branches don't. Another strategy I've seen used a lot is using tags, and these same filters in the CircleCI YAML work for tags as well. So if you have a policy that nothing moves to production or even gets staged to production until it has a semver tag on it, you could write a tag expression that matched to regex for semver So there's a lot of different things that you can do there, and it's kind of a whole presentation in and of itself.
Very cool. Sounds like we might have a future topic decided for us already. Where do you set the parameters that are sent to each job?
So the parameters that you define on a job, right? So for instance, this job right here, which is my DigitalOcean build and push, which builds my Docker image and then pushes it to the DigitalOcean registry. I define what parameters the job can accept in here. And so it's just a stanza that starts with parameters. I've got 3 different parameters that I'll take: tag, registry, and image. Those can have a default. You give them a type and then a description. Now, the way that parameters get actually pushed into these jobs is through the workflow. And the workflow down here, I've defined this particular workflow. I'm calling it DevOps flow. But you can see that on this second job here, this build job, I've actually, in this particular case, I'm using the matrix feature to pass in the parameters to the job. However, down here at the DigitalOcean build and push, I'm not using matrix. I'm just specifying the parameters as part of the workflow job definition. So tag is pushed in here, image is pushed in here.
Thanks. How do you integrate 2 repositories in one pipeline in CircleCI?
So basically CircleCI, in order to do that, you'd have to call the API in order to trigger your pipelines from one repository's pipeline jobs to another. We generally take kind of a stance of having like a one-to-one correlation between your pipeline that's running and your project that ran it. And so in order to do like multiple pipelines out of one job or out of one, GitHub repository, you'd have to use the API to trigger out those other pipelines to run.
Got it. So does CircleCI create a new container for each job? Does it take a long time to pull the image each time and run the job? And if so, how can we minimize this time?
So CircleCI does start a new container for each job that you run, assuming that you're using the Docker executor. And so what we do to minimize that is that our fleet of instances that are running these jobs utilize local layer caching in order to speed that up. So, once a particular layer cache starts, propagating throughout the fleet, those will start to speed things up. Also, when you're building images, you can turn on the Docker layer cache, which basically starts caching the layers that you're building on SSDs under the hood that are shared by the instances that are building your jobs. And so that starts to speed things up considerably.
How can we provide dynamic variables for a job like git hash code or something?
So dynamic variables, you could obviously bring those in, doing various different ways. One way to do it would be to use the API in order to start your job, where you could specify parameters dynamically for, those jobs that you want to run. Obviously, you can also, set environmental variables, and there's various different ways you can do that kind of on the fly. But I'd say if you really want highly dynamic variables, you're probably going to want to start your pipeline from the API.
Awesome. Well, we still have a few more minutes left. If you have any other questions, please feel free to type them in the chat. We'll give it a few more seconds here. All right, one more question. How can I create a new customized orb?
So we actually have some great documentation online about writing your first orb and how to publish those. So I'd refer you to the CircleCI documentation on that. And we even have a little project that's kind of a getting started with orbs. And so feel free to Google that out, and I think that you'll find the documentation is very helpful.
Cool. Are the environment variables shared across executors or orbs?
So there's two types of kind of environmental variables that you can define within CircleCI. One are environmental variables at a organizational level, and so those will be shared across all the different projects within your organization. Now the other are secure contexts, and so secure contexts are not shared by default across any of your projects or your pipelines. You actually have to specifically state within your definition here that you want to use a specific secure context for this job. And we can set limits on who is actually able to use what secure context. And so you can basically do kind of separations of roles there where you can say, okay, only the deployment team can actually access the secure context that has the deployment keys in it, whereas the development team can access the secure context that has kind of our dev environment keys in it. So that's the way you can kind of manage those secrets and how they're used.
I believe this is the last question that we have, unless someone else adds another one. How can we bypass a failed job?
So you can basically specify in your CircleCI YAML that certain jobs are allowed to fail, and that way the job can bypass even if it fails. There's obviously going to be cases like that where a job is either not super reliable, or maybe it's just doing something like linting and you're not really super worried about it failing. And so there's support within the CircleCI configuration language to bypass those.
All right, thank you so much, Jesse, for this wonderful presentation. Do you have any final words of wisdom for our attendees today?
I'd say, it's very easy to get started with CircleCI. CircleCI gives you a lot of free credits to get up and going. DigitalOcean is the perfect Kubernetes environment to get started with as well, because it's dead simple to set up a Kubernetes cluster and get it running and then start scheduling your deployments onto it. So I think it's kind of a perfect mix if you're just kind of getting started and you want to start modernizing your workflows and your pipelines. And thank you everyone for coming, and thanks to DigitalOcean for hosting.
All right, thanks for everyone for tuning in, and fill out the survey at the end to tell us how we did and what topics you'd like to hear more about in the future. We hope to see you again soon. Have a great week.